to do this a lot moving forward, and it's called rationalizing the denominator. Okay, part 3. So it comes from a division problem. So it always has a fraction. That's why it says the word denominator. And you're going to have to do this when you have a non-perfect underneath the fraction bar. We're not going to be able to have that moving forward. So let me give you an example. So let's look at example 1 here for this part. Let's say we have the fraction of 9x over 2. So remember, that is dividing, and we do want to try to simplify first, and we can. We can take this 9 out, so sometimes it's a little bit easier to go ahead and break it up. So I can take that 9 out by its root. Here's what it's going to look like. All right, so that square root underneath is no good. That square root on the top is totally fine. We just got to get rid of the square root on the bottom. Now, if you remember from part 1, right here, remember, my highlighter just broke. Whenever you have a root times itself, the root gets knocked out completely. So this is exactly what we're going to do in part 3. We're just going to multiply the top and the bottom by the root. So let me just go to a new line in my work so I can show it all at the same time. All right, just going to recopy this exactly how it is. Remember, this is not a equation, so we can't change the value of it. But if I multiply by root 2 over root 2, just remember that's a value of 1. 1 times anything doesn't change the value. So when we multiply straight across, this is going to be 3 times the root of x times the root of 2 over root 2 times root 2. All right, so we're going to clean up the top. We're going to put the 2 and the x together. And again, neither one of those are perfect, so it stays exactly how it is. Root 2 times root 2 is just this. All right, so let's look at one more example, and then if you know the little shortcut on this, by all means use it. You're going to get pretty comfortable with this, where you're going to go from here straight to here for sure. All right, let's look at example 2. Okay, so for example 2, let's write down the square root of xy on the top divided by 3x. Now again, if I wrote this all together, those x's are going to cancel out. So essentially what we're going to have is the square root of y over the square root of 3. And you're going to multiply the top and the bottom by the square root of 3. When you multiply the top by the square root of 3, you're going to stick them together like that. Check to see if you can simplify, but you can't simplify on that. And then root 3 times root 3 is just 3. Now be careful. I've seen some of us try to cancel those out. That's a whole number 3. That's the square root of 3. So those don't cancel out because those are not like terms. So that's going to be the final answer on that. So very quickly, let's just talk about a really super shortcut. So just moving fast and efficiently. If you have 1 over the square root of 5, that square root of 5 goes on the top, and then plain 5 goes on the bottom. That's always going to be your super shortcut. So if I had the square root of 8 over the square root of 24, be careful. Always try to simplify first. That's 8 over 24, and that's going to be 1/3. Now look, 1's a perfect square, so this is going to simplify into 1 over root 3. So to rationalize the denominator, it is going to be 1 times root 3 over root 3. So that's kind of the little shortcut, and again, if you can recognize that, that's great. If you were like, I have no idea what she was doing, where that came from, just remember that goes all the way back to multiplying the top and the bottom by this number right here. And And we'll talk more about that tomorrow, and if you have questions, by all means, let me know. But if you do know that shortcut, you do not have to show all that work. If you don't know that shortcut, you come talk to me and I'll help you. It's not a big deal at all.